Hello students, I am Aisha Siddekha, Assistant Professor of Chemistry working in Government First Grade College. In this video, we are going to learn about the continued part of alkalides for session 25 for the B.Sc students who are studying chemistry in the 5th semester of the Tumkur University. After going through this video, you should be able to understand the structure of nicotine and the synthesis of nicotine. In the previous video, we learnt about what are alkaloids, definition, classification, general characteristics, as well as some important alkaloids like quinine, conine and piperine were taken and the physiological functions were understood. Now coming to the structure of nicotine, it is a principal alkaloid of tobacco which is consumed in various forms as cigarettes, in rural area as BDs, and it is also chewed also. In the purest form, nicotine is colorless and a odorless liquid, and it is having an oily consistency, and this is the structure of nicotine. Structure of nicotine. Physiological function, it acts as a nerve stimulant. That is the reason why many people they consume this in various forms. But at the same time, taken in smaller quantities, it is used as insecticide and also for vermifuge. It also acts as a vermifuge. Now let's start off with the structural elucidation of nicotine. It has got a molecular formula of C10H14N2 as determined by the elemental analysis. So the first thing that we learn about the factor is how this nitrogen is present. We all know that alkalides are basic in nature. So here it does not give any acetyl or benzoyl derivative with acetic anhydride or benzoyl chloride, indicating that both the nitrogens are present in tertiary state. They are not free. So therefore it is a diacetic base or ditertiary base. On oxidation with KMnO4 or nitric acid, it gives nicotinic acid, indicating that it contains a pyridine in its structure along with a side chain, which is the remaining number of carbons and hydrogens and the one nitrogen at position 3. When this nicotine is treated with zinc chloride, forms nicotine zinc chloride complex is there obtained, which on distillation with lime gives pyridine, pyrrole and methylamine, indicating that along with pyridine it may have a pyrrole or pyrrolidine ring in it. The side chain structure was further confirmed by the treatment of nicotine with concentrated hydrogen iodide at 150 degrees Celsius. Methyl iodide is formed along with another compound having the molecular formula of C9H12N2, which indicates that the methyl group, the nitrogen is free, it contains a N-methyl group. N-methyl group is present. Since methyl iodide is formed, it breaks away and forms methyl iodide. Therefore, there may be a N-methyl group in this structure. Then the reaction was carried out with methyl iodide. This indicates the formation, hygrenic acid is formed. This is hygrenic acid. And it indicates that there is N-methyl pyrrolidine group, not the pyrrole group. The side chain may be N-methyl pyrrolidine group, which is attached to the pyridine either at carbon 2 or carbon 3 of pyridine. So nicotine on treatment with hydrogen iodide and methyl iodide forms nicotine isomethionide, which further undergoes various reactions to form the hygrenic acid, indicating that the side chain is pyrrolidine ring. By all these reactions, and considering that it forms hygrenic acid, this was the structure assigned to nicotine. Synthesis of nicotine, starting from cyanopyridine. This is cyanopyridine. It is treated with ethoxypropyl magnesium bromide, organo. This is a Grignard reagent, and further reaction was carried out with hydroxylamine to give a compound like this. Later on treated with zinc acetic acid, hydrogen bromide at higher temperature, and finally methyl iodide in presence of a base gives the nicotine, and this confirms the structure of nicotine. The possible questions on this topic are: how do you show that side chain of nicotine is pyrrolidine derivative, and which reaction is used to fix the position of side chain, and explain how the structure of side chain is determined. Finally, descriptive questions: nicotine derivative, how nicotine is synthesized, and how do you what happens when nicotine reacts with chromic acid and hydroiodic acid.